show. But let's get started. The beginning, in any case, is kind of a shameless plug for the Master of Architecture program, so maybe I'll do that really quickly first. Hi, I'm Peter. I'm an assistant professor for architecture and sustainable design. I'm also the coordinator for the Master of Architecture program here at SUTD. In the context of SkillsFuture, right, which is the talk or the event today, we bring in not only our own students, straight from undergraduate, but we bring in a lot of people that are a few years into their career, about 7 years in, who are looking to take the next step, become qualified professionals, learn new skills, try out new ideas, because being in the profession for a long time can get a little bit same, right? Always working on the same kind of stuff. So this is a project by our student Benedict Tan, one of our Master of Architecture thesis projects. The thesis is kind of a chance for our students to develop a research focus or an expertise that they're interested in. So within the SUTD program, we've been developing Master of Architecture labs. These are kind of research design groups that are focusing on different problems. We started this last year. There's a few topical areas where we think we can have kind of pretty good domain expertise and help our students craft the next projects and define their position for their career going forward. We have circular city, future building, future health, climate change, planning for climate change in future cities, and a group of individual advisors. So what I'll tell you a bit about today fits under this circular cities lab. Although the work, so 2 students are joining actually to share their work, and this is from undergraduate, but they're sharing their work. So the Circular Cities Lab is led by me and Carlos Bagnon. We're looking at the idea of circular economy across scales, from the scale of product to architecture to the scale of the city, and collaborating internationally. So next week I'll be at Aalto University presenting a lot of this work for their summer school on circular economy. Carlos's work focuses on additive manufacturing and its applications to circular economy. So this is recycled PET plastic that he's transformed into a lot of different furnitures and designs. So from the scale of the product to the building. This is another product of Carlos's where he went to HDBs. He did a full inventory of pieces of just kind of everyday fittings for HDB units that were going to be discarded in the HDB that was being thrown away, and he's developed a way of creating new housing out of it. My own research focuses on design optimization for this circular economy, right? So I created a sort of furniture set, which is created entirely from recycled materials that assembles really quickly, has entirely only friction joints, so there's no added glues or fasteners. Really easy to reuse, and at the end of its life, it's really easy to recycle as well, just a single material. For this, I actually went through a whole workflow of optimizing it, looking at the entire life cycle, looking at a wide variety of different materials, structural scenarios, design configurations. I published this in a journal that came out recently. So it's kind of a design activity, but also a research activity for me. At the same time, I do work at the urban scale too, so hence circular cities. So this is a web-based tool that we're developing for the Urban Redevelopment Authority that, given a specific plot, develops the kind of optimal resource-efficient development for it. What you just saw there is streamlines too, to kind of look at the most efficient geometry for the subdivision and road network on the site, right? To maximize the use of scarce resources. What we're going to talk about today is kind of a one-off studio project that we did was end of last year, with Singapore Airlines. It's an upcycling project. We call it the Upcycle Studio, and we worked with SIA to take parts from their airplanes and transform them into new products. So really quickly, I wonder how useful this is for all of you, but I want to share with you a little bit about my personal experience with circular economy, where I started as an architect. So this is a project. I didn't design this. One of my first employers as an architect designed this in Boston. This is called the Big Dig House, and I think you all noticed that there's something very strange about this house, which is this massive piece of structure that's coming out of the side of the house. That's not typical for residential construction. This is part of a highway, right? This is a part of the highway that became obsolete in Boston, was demolished. And John Hong, his office was called SSD, it's now called Project Architecture, won a competition to reuse these parts of this highway to make new buildings. So this is essentially the process. As the highway was demolished, the house is actually for an engineer who's working on redeveloping the highway. They took the parts, they brought it to the site, and assembled the house in just a few days, which is really fast because they're these prefabricated highway components. And I worked with John for several years. He was my mentor when I was starting my career. So upcycling was really kind of a big focus when we were starting out. And John was always frustrated that the highway was a massive project. In terms of quantities of materials, it's enormous. And his vision was that, at the urban scale, we could take these materials and we could build at a large scale. We could make a real difference in terms of the carbon footprint of the city, in terms of the waste in the city. But all that he was able to do was one house in suburbia. So he was always hoping that, well, maybe this will grow into something bigger. And, with increasing interest in green economy, I think that we can see a lot of hope, for circular economy in the future. This was early 2000s. I think that especially at the level of product, it's extremely promising these days. So I'm sure we all know linear economy, make waste, you buy it, you throw it away. It is incinerated, it goes to a landfill. It's extractive, right? It basically depletes our natural resources in the environment. It's also polluting, right? So the waste goes out as an excessive or a secondary outcome from industrialization. Circular economy, the aspiration, of course, in this perfect circular economy exists in the world, is to kind of shortcut that process and take what was waste and bring it back into materials. And we can talk about all kinds of different cycles. I think we normally think about trash and recycling, but we can also think about other cycles, natural cycles, biological cycles, biomaterials. This is the UN's framework, UNEP's framework for circular economy. This is a great way of visualizing it because it reminds us that in circular economy, the way to retain value at the highest level is not to throw something away, grind it up, and recycle it, but actually to reuse it as much as possible, or not to waste it at all in the first place. So I think when we're talking about upcycling in this studio, we're in here somewhere, right, where we're trying to reuse materials and retain their value as much as possible. I'll go through the rest really quickly. As architects, there's a lot of writers that were early to the upcycle movement, like William McDonough, that were sharing with the students. There are lots of early projects. We looked at Expo 2000 with the students, but a lot of these projects have a downside too, and some of these temporary projects didn't pan out in the way that we imagined. There's been a new generation of these kind of circular economy upcycling projects that have happened, in particular in Europe. I think the work of Space and Matter Metabolic in Amsterdam is really well known. They have a project, the Koval, and this focused on reusing houseboats to regenerate a site that was a post-industrial site in Amsterdam. It also became a kind of catalyst for a whole urban master plan. So what started as a kind of standalone site, essentially architectural, became an urban plan for a big chunk of the north of Amsterdam, and with a great deal of success. I think David Bledek is even writing the requirements for new development throughout the rest of Amsterdam now, looking at urban metabolism and circular economy. So, with these examples in mind, we came to this problem of taking windows from the A380 and imagining what it could become in our kind of small studio last year. So we took this as an opportunity to work not only with assessment and upcycling, the sustainability side, but with digital design and digital fabrication to try and make projects that were sort of engaging, optimized, and responsive to the needs of the user, of the client. Hey guys. Hey Daryl.
Hi.
Thanks for coming. Thanks for coming, man. There's also a lot of really inspiring upcycling projects out there. I don't know if you are all fans of design for circular economy, but these projects like CODA, this is Caroline O'Donnell in the U.S., really fun imaginative projects that kind of show that what we think of as waste is actually beautiful and something that we can use to craft our environment. The challenge I gave to the students was to take the windows from the A380 and create a Wunderkammer to create essentially an exhibition space, a kind of pop-up museum for Singapore Airlines with the materials that they had. They had a little bit of extra material that they could use, plywood sheets, aluminum sandwich board, which is a kind of cardboard, and 3D printer filament. And what they got was this. They got 100 of these. So this is from the A380. It consists of a rubber gasket along the exterior and 2 sheets of, I believe this is acrylic, right? So a thicker sheet and a thinner sheet here. There's also this piece of aluminum frame that connected the windows to the body of the aircraft. With this, we challenged them to take our fabrication equipment at SUTD, work through a kind of design prototyping type of methodology, and produce something by the end of the term. We did some digital design workshops, component-driven aggregations using WASP, and I think just to kind of summarize the outcomes of the studio in terms of like what is design for circular economy or what we learned, there were 3 big things that came up. We kind of learned these along the way too. Upcycling, you have to test the project. It is hands-on. You have to test the material as you work on it. You have to have a very clear method of circularity assessment, and you have to use that to drive the design. If you don't have that, there's all kinds of distractions that will make it inefficient, excessive. And adding on to that point, limit the addition of new materials, right? I think there's a temptation to kind of have a kind of a desired output and push towards that. And I think when you're doing upcycling, you really have to let the material lead you in the process, which was something that we learned as we went along. So yeah, we had to not only measure the mass of the components that we were working with, but we also had to look up the correct carbon factors so that we could estimate the GWP, the global warming potential, of the acrylic, of the rubber gasket, of the aluminum. We got these mostly from the environmental product declaration forms for associated or similar materials. We did scanning of the geometry, the windows of curve, right? I think often when you're working with upcycling, these are kind of non-standard components. You have to be kind of clever about how you work with them and combine them. We also tested them under different kinds of stress, right? We ran them through the CNC mill, we heated them up, we tried to polish them, bending, tension, and it's quite strong, right? It's a material for an airplane, but eventually it will fail. Right? Adhesion is another material property that we tested. And with that, we did this assessment, right? So we were asking students in their design, think about the amount of material that you're bringing in that's upcycled, think about the amount of material that is new, and not just comparing the mass, but comparing the GWP, right, the global warming potential. So like even bringing in a small amount of aluminum can throw this calculation off just because of the high amount of embodied energy in the aluminum. And we were asking them to take this fraction, right, of new materials added, global warming potential of new materials added over upcycled materials, bring this as close to 0 as possible. How far can you take it? At the same time, we didn't want to be too, or at least I as the instructor didn't want to be too dictatorial. because you should have fun with it. It should be creative. You should create the product that you want. So we have to find some balance with this. Yeah, and with that, I mean, I think that metric helped us a little bit to reduce the amount of material. So this is one of the projects that you may have seen downstairs. It's essentially a display case made with the windows. They started with something that used a lot of plywood, and we did a radical redesign halfway through and reduced it to almost nothing, which is a PLA print, some bolts, and the windows. I mean, I was quite happy with that, reduction in the use of materials. And of course, there's a lot of kind of practical prototyping work that we have to go through as well. I think you can see some of these downstairs. Oh yeah, so this is an interesting problem too. Is these students had this kind of idea of a modular unit that they wanted to create, and during the course of the term, the challenge for them was to make it as small as possible, use the least amount of material, new material, while still retaining the function of acting as a display case. So it's a bit different from a typical architecture studio where you have your design and you kind of produce it at a standard, and maybe over-dimension scale. We really try to push the dimensions to the minimum. And yeah, some digital challenges too, right? Where it looks great on your computer, but then when you actually try to make it, it doesn't work the way you imagine. So I was really happy with the outcomes, midterm, final. Even with offcuts, they were able to make a bench for this, midterm final. This is the project that you guys will share now, so I won't say too much about this, but I was really happy with this too in terms of the way you guys were able to minimize the use of materials from your initial vision to the final product. Another really nice use of digital fabrication on the window. Great, so Charmaine and Ian, do you guys want to come up and talk about your product a little bit?
To upcycle FM windows within a boundary of 3 by 3 by 3 meters. So we started off with a vision to actually create a playful collage of, sorry for the formatting, but our vision was to create a playful collage of stackable seating units that users can freely move around to separate them as individual seats or put them together to form a larger structure. So the materials, then this engagement actually promotes curiosity among the users to find out about how the materials are being upcycled, especially the airplane windows in each individual module. And then also it demonstrates to the public how upcycling can be done in a fun and engaging manner. So we actually started with our inspiration as a beaver bird's nest because due to the nature of the materials being provided, airplane windows, we were inspired by the idea of flight. So that led us to birds and eventually their nests even. So we were inspired by how this beaver bird nest was put together with a large variety of materials and also how it provides a cozy resting space. At the same time provides shade for its users. So at the beginning, we began with this circular form and then lifted one side up to actually maximize the 3 by 3 by 3 meter space. So we created an intimate space by doing so. And then next we actually sliced it into 8 sections to create a structural cross section, and then we proposed weaving pattern through the windows as well as the cross sections to actually create a semi-enclosed structure. So this was the design that we eventually ended up with at our midterm, so after 6 weeks of working on the design. And after presenting this design to a panel of jurors, we actually got some feedback, and then we actually summarized that feedback into 3 key points. So the first one was actually about how to incorporate the airplane window elements to be integral to the design of the pavilion. And secondly, to find a more suitable material for weaving through the windows. And about testing that material, because we actually proposed rattan without actually physically weaving through rattan through the airplane windows, because and as a result we weren't actually very sure of like the flexibility of rattan or how suitable it was to be weaved through the airplane windows. And lastly, it was also to explore how we can push the design of our structure to create a system which included more circularity processes. So post mid-review, we actually decided to incorporate the airplane windows as structural elements instead. So we iterated on the design of each module such that it offers greater flexibility when creating larger forms. And after prototyping and experimentation in 1:1 scale, we did further iterations to actually reach our optimal design. So with an increased focus on modularization of our pavilion, our design can actually operate at 3 different scales. So firstly, it's for individual use, and then for pavilion use, and as well as for large communal spaces. So the design actually utilizes the thick airplane windows as structural members to hold the roof together, giving the windows a new lease of life beyond their original use, as well as creating a modular system. So Nick Eating will bring you through how we actually went through the digital fabrication and physical prototyping process.
So to understand like why we shifted, we had a large shift since like the mid review from a more form-driven design to a more modular design. It has to do with how we started with digital design, basically coming up with a form on our computers before actually having our hands on the windows to actually test out the rigidity or what are the sort of constraints that we have as students using this material. That was very new to us. So actually when we actually got our windows, which was post mid-review, we realized that a lot of ideas that we had initially were not as doable. And by scaling it down to a smaller scale, we can actually perform more and in a different way rather than just a form-driven design. So to start off with how we sort of envision our module initially, we were thinking of what we can do with the windows because we didn't actually know or we weren't sure whether or not it was even possible to have holes or how to drill holes, how to create holes in the windows. So when we started off, we used the thin windows, and what we did was we envisioned using this, putting these thin windows under a laser machine to laser the thin material because it has a certain constraint to how thick the laser machine could cut through the material. In between these, we've slotted in wood or plywood sheets, and you can see that this was there's this formation of an X that sort of played into how we wanted to aggregate it in the future, which meant that if I took one of these modules and put it to the other side, it could slot within these two holes, and if I could do it the same on top of the entire module, making it a more usable in a sense if we want to create a larger form. And of course, in between, we would be weaving instead of rattan, cotton cord instead. So the idea of the stacking can be shown here. You can see that we can aggregate it into larger forms and eventually operating in the 3 different scales that we mentioned before. And the total amount of materials, new materials that we added is actually quite minimal, which was something that we wanted to try to achieve to reduce the amount of additional material, in this case plywood, that we are adding to this project. So, like I said, we tried using, we used the laser machine to actually cut the holes as well as the holes around the entire window for the actual weaving. Initially, we started off with greenboard scale to test out test out the actual shape and dimension before actually using the windows to do this. And for the plywood sheets themselves, we actually used a wood router to do the routing. So what we had was a very, I think when we started to assemble it, we realized very closely, very early on that, actually some of the material thicknesses don't really look suitable for someone to be sitting on, which was a problem that will surface later on. So when we started weaving, we had to experiment with how we weave this project together as well. It was easy for us to design it digitally to say, oh, it does weave, but when we were doing it, it was a bit more difficult and challenging than we expected. But nonetheless, our first prototype was done, I think in a matter of maybe 2 weeks, because we had to rapidly prototype as we weren't sure if this initial setup would have worked. So initial testings were alright, but we realized that this was just a laptop bag, and you can see that from this image that the window started to sag slightly already, which wasn't good. So naturally, the next step to go was me trying on and seeing how well it would bear weight. And in the end, I tried sitting on it, which was a bit dangerous, but yeah, we can see what happened in this slide. So there was a level of catastrophic failure. After I sat on it, there was a large crack, and it was the windows were permanently bent. So as in this image, you can sort of see, visualize what happened in this prototype. So because of the X arrangement of our plywood, you can see that there's uneven distribution of weight. Because when I sat on it, the string started to tug at different locations, but only certain spots were braced on by the plywood. So as you can see, it started bending in this in this direction, and eventually it cracked where the holes were, because that was where most of the weight was run by the plywood. So after this, we realized that there was also a few design failures that we didn't foresee. One was that by placing the plywood flat on where it was supposed to sit, it wasn't actually bracing as much weight as well. So we changed the orientation of the wood support, while also making sure that both top side would be able to brace enough of these forces when we sit on it, and yeah, and simplifying the design in a way, making it more elegant, because the initial design was a bit like a plastic wrap. So on this design, I went for Y-shaped configuration. There was still a level of crisscrossing, but in this way, because of how some of the supports were stacked on, it was able to support, it would theoretically be able to support more weight on it. And for the weaving, we didn't see much issues with the actual weave, since none of the ropes actually broke, which was a good sign, so we kept it as it is. And in terms of application, there was a slight difference in how we did it from the beginning, but the idea is still the same, how we can attach each unit with one another in different ways to create a larger form for different scales of use. So one thing that we also tried to do was to see how we can play around with the weaving, because actually when the weaving happens, you can skip as many holes as we would require to create a different form. Yeah. So and during fabrication, we realized, because of when working together with another group, we realized that we can actually use the wood router to drill holes or slots into the windows, which meant that we could actually make use of the thicker windows, which would give more structural strength. So in order to do that, we had to have a rig to hold down the windows, since the windows were not of a regular shape. And then, yeah, once bolted down, the wood router would create the slots and the holes where we require. And in terms of the actual plywood structure, we doubled up the thicknesses to ensure that it will be able to hold on more weight. So the assembly process was kind of smooth. We were quite happy with the result, even though there were a bit of tolerance in terms of like how we wanted or what we envisioned it before. I think we were happy of the results. So you can see some of the ways that the aggregation could work. But given the amount of time we had, we could only create one full prototype, and along with more frames than the actual product. So eventually the assembly works out well, and then the testing begins. So by this time we didn't have much time also. There wasn't enough time to make a new product or new prototype, but the testing was still essential for us to gain knowledge of whether or not our project would have held on. So luckily, even though in this picture you can see that there was a bit of bending as well, but actually it was totally fine. In fact, the sagging here as well made it so that when you're actually seated onto the the module, it gave it a little cushion-like feel. So it's not like you're sitting on thin air. And what it does actually is the sagging, if you see in this picture, helps because it braces you. You're actually sitting most of your weight onto this main structure. And the tension from the cotton cord actually creates a cushion feel for the seat, making it nice, rather nice to rest on. So it was kind of a success. So we also tried to test much more, stress test to see if it was viable. So you can see that like when we sat down, we didn't try to like brace our home weight as well. Even shifting the weight from left to right, you can see that there is a bit of movement onto the actual seat, but there wasn't any structural damage done to the module itself. So finally, these are just some technical dimensions of the details of the module. They're actually quite small in size. So if you actually saw our booth at the campus center, you can actually see how small it is, and it's also very light. And in terms of the amount of materials that were used, it was also, not too much.
So in the single module, we used 32 meters of cotton cord, 0.47 meters square of plywood, as well as 2 big acrylic sheets. So each of the acrylic sheets actually weighed about 1.2 kilos, and in total, our GWP for 1 unit is about 1.41 carbon dioxide, 14.1 carbon dioxide kilos of carbon dioxide equivalent. And then our GWP ratio of new materials, which is the plywood and the recycled cotton cord over the thick acrylic sheet, is actually 0.41. So the assembly of each module was actually simplified for streamlined production as well as ease of maintenance by the users. So the unique shape and orientation actually minimizes the use of wood without compromising on the stability of the structure. So these are a few steps that we actually have in a sort of a manual for users to actually assemble the structure. So it's just basically assembling the 2 X legs and the Y legs together, and then eventually assembling the windows, and then moving on to the weaving. So the weaving, assembling the wood structure took about like a minute or 2, but the weaving took a bit longer. So we actually put more care into the instructions of how to actually weave and the directions to do so. And eventually each module could actually be connected to one another, both horizontally and vertically, to actually form larger congregations for use in different settings. So these are actually some alternatives of the materials for the string and wood in case users require them if they actually broke certain materials or certain materials actually wore out. So we actually included the strength, durability, stiffness, and density, and even cost, so that users could actually make more informed decisions when they choose which material to actually replace their product with. And moving on, we actually explored how our entire product is circular. So we based on design on 2 main principles. Firstly is to eliminate waste and pollution, and secondly is to circulate the products and materials within a cycle as well. So firstly, we started with the 2 different types of materials, the finite materials and the renewables. So the finite materials actually included the acrylic. The renewables is actually the energy that's required to produce this structure, the natural fibers and the wood. So how this actually goes into the cycle is actually that the raw materials, which is the wood and natural fibers, would actually be taken in by product manufacturers like IKEA or furniture shops to actually make our furniture product. And involved in the process would be like CNC routers as well as other digital fabrication methods to cut the holes within the wood as well as the windows. And then moving on, we actually have after the product is actually being made, it will be transferred to the service provider, which could either be consumers themselves or furniture shops, or even event management firms to assemble the furniture. And then this will involve putting the wood and window pieces together and then manually weaving the cotton cord within. So after the piece of furniture has reached the users can actually either use it themselves or share it with their friends and family. So in addition, if there's parts of the furniture being broken, it can be replaced simply by buying a new spool of string, for instance, of the cotton cord. So this bench can also be used and be distributed from individuals to small pavilions in indoor venues to large event spaces as well that require seating areas. So last but not least, materials that make up the bench can also be recycled. If solid wood is used in the product, it can be turned into plywood or particle board as well, and plywood and particle board can then be shredded to use as compost as well. So after regeneration of the raw materials in the biosphere, the wood and cotton can also be collected and returned into the cycle. So this is an overview of our entire circularity of our product. And then next here is a render of our large-scale kind of collage of all the modules being put together. So we can envision this to be placed in an indoor space, like libraries or shopping malls, whereby users can use it as a resting area, or even a meeting space, or even just individual seats. And then here are a few pen drawings, as well as isometric view elevation, which is about 2 meters in height, so not too tall. And how we imagine our entire structure to actually come together in a very large scale kind of format. Thank you.
Thanks everyone. It's a small group. We can take any questions or we can just chat informally. But yeah, thanks for coming by. I hope it was interesting. Can I ask where everyone is coming from? Is that okay? Are you coming from another institution actually, or?
Actually, I'm working.
Oh, okay. Oh, okay. Okay. Great. I mean, you're my neighbor, right?
Yeah.
So I know you. Where are you? Where are you
No,
from?
I'm just coming on my private capacity, yeah.
Oh, okay. Okay. Well, and you're from SMU, right?
Yeah.
Okay. Well, welcome guys. I hope it's interesting. I mean, in terms of SkillsFuture, we have the Master Architecture program that I coordinate, and we look at it as something that people can come into later in their careers and participate with. But I'm happy to chat with you guys also about, what is continuing education for green economy? What kind of modular courses work for people? I'd be curious to hear anybody's thoughts on that too. But otherwise, we can also just go get a coffee before the next lecture.
Right? About the project. Are there other parts of the airplane that can be used for this as well? For example, the common part of it, like the seat, would that be possible, or are there other concerns?
I think for our project, we focused on the airplane window as a part to be used. I think that was the given material, but certainly I think there were other materials that were used in other challenges, and which we weren't meant to use, I think.
For the architecture studio, they only had access to the windows and the aluminum frame and the rubber gasket. There was a separate challenge that was for throughout Singapore. It wasn't run as a studio, and for that they had some of the fabrics too. They had carpet and they had seat backs. This was just for the architecture studio itself. We had limited the problem to one specific component to work with. Yeah, you may have seen in the Straits Times they had some of the other student projects in the competition. They were mostly cut style projects, right?
I think that icon, is that here?
Yeah.
So I'm also curious about it. An airplane is a good example of a very large product or object.
Yeah.
My understanding is that Singapore Airlines always leases the planes. They never actually own them. So I'm just curious, maybe you're involved in the setup with SU, but was it like when you mentioned that they was retired, that they get to the end of their useful life, and I'm wondering, does the original owner, say Airbus, do they just say, we don't want anything to do with it?
As far as I know, this belonged to SIA.
Okay.
I went and saw the plane as it was being decommissioned. I went to the hangar and walked through it, and I asked for all kinds of stuff, by the way. I asked for the cowls around the engines, which are composite. They're massive. They're 3 meters by 3 meters, kind of these toroidal shapes. We could have done something really interesting with that. But actually those large composite components have huge value because they can be reused for another A380 later, right? So there's no way that we could give me that. But the windows, a lot of the interior fittings, there's just no secondary market for it out there. You know, they can't sell it on or exchange it to another airplane. So the windows, they're very happy to give.
SQ, let's say they owned all that thing, they considered it end of life, so just take it off our hands.
Yeah.
Whereas maybe some of the electronics or like you say the engines can still be refurbished and reused.
Yeah, so it depends on the component.
And how much, say for this challenge, how many different groups did you have? You know, like these two.
Yeah, we had 5 groups. We had 5 groups of students working on these. So there were 5 different prototypes, and I think 3 of them are downstairs.
Is it in that main?
Yeah, in the main, kind of in the back there, in the campus center. We have basically one module from each of them, and then the bookshelf we're using to show some of our ESP materials.
And then when you're teaching, is the GWP like one of the key things that you get across?
Yeah, so what we actually had was, we were making digital models. So in theory, we had a grasshopper model for each project. And with that, we had volume calculations for each material. And so you could dynamically know, in theory, you could dynamically know what the GWP ratio was. I think in a lot of cases, that wasn't actually what was going on, right? It was, once we actually started working with the materials, then it was a lot more hands-on. And I think after that hands-on portion, then we went back and calculated the volume and double-checked the ratio. Right? The work that I was doing, that furniture design work that I was showing at the beginning of the lecture, for that, I did develop this design, and then post that design process, I went through an optimization process to basically minimize waste, maximize the suitability design for circular economy based on a